Hi, I am Dr. J. Suresh Goud, Associate Professor in Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss the topic Test of Hypothesis for Difference of Means. Test of Hypothesis for Difference of Means. Before going to discuss about this topic, in the previous session, we have discussed Test of Hypothesis for Single Mean. Test of hypothesis for single mean. That means if the problem consists of only one sample, if the problem consists of only one large sample, then we can apply test of hypothesis for single mean by using the formula Z equal to x bar minus mu by sigma by root n to verify the sample came from the population with the mean mu or not. Now, in this topic, test of hypothesis for difference of means, here we are going to consider the two samples, not one sample. See, suppose if I take the first sample, its mean is x1 bar with the size n1. With the size n1. This sample, if I choose from the population with the mean mu1, first population, and SD sigma 1. I chosen this sample from the given population with the mean mu1 and variance, SD sigma 1. Similarly, if I choose another sample x2, its mean is x2 bar with the size n2. This sample, if I choose from the population with the mean mu2 and SD sigma 2. So totally two samples we are going to choose from two different populations. In this case, the test statistic Z equal to x1 bar minus x2 bar by under root of sigma 1 square by n1 plus sigma 2 square by n2. This is the test statistic in step 4 for test of hypothesis process. After getting Z, we can calculate mod Z. And in step 3, we know that we can choose Z alpha value. Now, if you compare these two, according to the procedure of test of hypothesis, either we can accept or reject the null hypothesis. If you observe this test compared to the test of hypothesis for single mean, only the difference is there we have only one large sample, here we have two large samples. So this is the test statistic formula, which is Z equal to x1 bar minus x2 bar by sigma 1 square by n1 plus sigma 2 square by n2. In case, see, Z we know that x1 bar minus x2 bar by under root of sigma 1 square by n1 plus sigma 2 square by n2. Sometimes we don't know this sigma 1 and sigma 2, the standard deviation of the two different populations. If we don't know these two values, we can replace with S1 and S2, where S1 and S2 are standard deviations of the samples, two samples. If the standard deviation of population values are not given, we can use the standard deviation of samples. So in that case, we can replace Z equal to x1 bar minus x2 bar as usual by under root of, instead of sigma 1 square, we can replace with s1 square by n1 plus s2 square by n2. This also we can use as test statistic in test of hypothesis for difference of means. Suppose if samples are drawn from the same population, see here we have chosen two samples with two different populations. But if the samples, two samples we have chosen from the same population, that means the standard deviation of the population, two different populations are equal because we are choosing from only same population. In that case, we can change the formula x1 bar minus x2 bar by, instead of sigma 1 square, we can write as sigma square only, because only one population SD is there, by n1 plus sigma 2 square by n2. So according to the problem, we can use any one of these three formulas. So this is the general formula, x1 bar minus x2 bar by under root of sigma 1 square by n1 plus sigma 2 square by n2. In case if sigma 1 and sigma 2 are not known, we can use s1 square and s2 square. If the two samples came from the same population, instead of sigma 1 and sigma 2, we can replace with sigma. So this is the introduction of test of hypothesis for difference of means. Now, coming to the problems on test of hypothesis for difference of means. In the previous slides, we have discussed about the understanding or the concept of the test of hypothesis of difference of means. See, according to the problem, we only identify which test is suitable for the given problem. So I will explain you how to choose, how to identify the suitable test for the given problem according to the description of the problem. See, if we read the problem, the means of two large samples are given. First sample size is 1000 and second sample size is 2000. Their means are 67.5 and 68. See, according to the first statement of the problem, first we need to write what values are given in the problem. See, two large samples with sizes. So sample size is n. Two are there, that's why n1, n2. The first sample size 1000 is given and second sample size 2000 is given. So 1000 and 2000 are large samples because more than 30. Their means are 67.5 and 68, which means two sample means. Sample mean is denoted by x bar. But two samples are there now, that's why x1 bar, x2 bar. Their means are 67.5 and 68. According to the description of the statement of the first problem, these values are given. n1 1000, n2 2000, x1 bar 67.5, x2 bar 68. Now, can these two samples, be regarded as drawn from the same population? Our question is, or our problem is, can these samples be regarded as drawn from the same population of SD? We are going to test these two samples. These two samples are drawn from the same population with SD. Which one SD? Population SD. Population SD is sigma. Only one population is there, sigma equal to 2.5. We are going to verify the given two samples have drawn from this population with the standard deviation 2.5 or not. This is the problem. At 5% level of significance, that means alpha equal to 0.05. So, the description, according to the description of the problem, which test is suitable for the given problem? Is it suitable for test of hypothesis for single mean? No. Because here we have two samples instead of one sample. Then, is it suitable for test of hypothesis for difference of means? Yes, because we have two large samples. In case if the problem consists of two large samples, we are going to use test of hypothesis for difference of means only. So, sigma value and alpha value also. 5% is nothing but 0.05. Now, the procedure of test of hypothesis. First, we are going to set up null hypothesis. There, in test of hypothesis for single mean, we fixed null hypothesis is mu equal to something, the particular value for the population mean. But here we are going to define the null hypothesis is x1 bar equal to x2 bar. That means there is no difference between the means of two given samples. Actually, the mean of the first sample is 67.5 and mean of the second sample is 68. What we have taken, there is no difference between means of the two samples. The null hypothesis is denoted by H0, the symbol. Like this, we should fix or we should set up null hypothesis for t-test for difference of means. Now, alternative hypothesis, we know that, which is against to null hypothesis, H1. The against to null hypothesis means actually we have taken null hypothesis is x1 bar equal to x2 bar. Against means x1 bar not equal to x2 bar. Now the level of significance alpha value 5% level of significance is given. Here bar x1 bar not equal to x2 bar means two-tail test. We defined which is two-tail test because not equal to is there. In case if it is greater than, we can write as right tail test. In case if it is less than, we can write as left tail test. But not equal to is there. That's why we have to write two-tail test. Now in level of significance, this value we have chosen from Z distribution table at alpha equal to 0.05 for two-tail test. For two-tailed test. Now step 4, as we have discussed in the introduction, Z formula x1 bar minus x2 bar by sigma 1 square by n1 plus sigma 2 square by n2. But sigma 1 and sigma 2 both are same because here in the problem given that only one population, that value also given 2.5. Now x1 bar we know that and x2 bar we know that, sigma also we know that, n1 and n2 also given. So all the values you substitute, x1 bar is 67.5, x2 bar is 68 by sigma 1 which is equal to sigma 2 which is also equal to sigma, that value is given 2.5 whole square by n1, first sample size 1000 plus sigma 2 where sigma 2 is also known as sigma because we have only one population, sigma 2 whole square by n2 where n2 is 2000, the second sample size. If we simplify this term, we are going to get Z equal to minus 5.16. So we can take mod Z. If there is any negative, we can take as positive. So in step 4, mod Z equal to 5.16 and in step 3, Z alpha equal to 1.96. In step 5, we can compare these two. So mod Z is greater than Z alpha. That is in the conclusion, the test statistic in step 4, that is 5.16 and Z alpha we got it 1.96. So mod Z greater than Z alpha. According to the process of test of hypothesis, if you get greater than, we can reject null hypothesis. What is null hypothesis? x1 bar equal to x2 bar. This is we are going to reject. That means x1 bar not equal to x2 bar. Right? Now what my question is there any error, type 1 or type 2 errors in this procedure? No, because x1 bar equal to 67.5 and x2 bar equal to 68. Both are not equal and I proved that both are not equal. That's why there is no error in the procedure of test of hypothesis for this particular problem. So that's why we are going to reject the null hypothesis because mod Z is greater than Z alpha. Like this, we have to solve the problems on test of hypothesis for difference of means. In examination point of view, we only should identify which test is suitable for the given problem. For the given problem, blindly we should remember, in case if we have only one large sample, we are going to use test of hypothesis for single mean. In case if the problem consists of two large samples, we are going to use t-test for difference of means. Now coming to second problem, First, we need to read the statement of the problem. The mean of wheat. Everyone, we know that what is the meaning of wheat. The mean of wheat from district A. One district consider, which is 210 pounds with SD 10 pounds per acre from a sample of 100 plots. So district A means one of the sample with how many plants? 100 plants. So N1 equal to 100. Its mean X1 bar 210 and its SD S1 10. So N1 100, X1 bar 210 and S1 10. S1 10. Now, in another district, that means district B, its mean was 220 pounds. X2 bar is 220 pounds with SD 12. SD 12. From a sample of 150 plots, second sample, 2 samples are given. Assuming that the standard deviation entire state was 11 pounds, we are going to consider entire state as population in this case, because the 2 different districts, if you consider as sample, the entire state we can consider as population. That standard deviation is 11. That means only one population, which is state. Our problem is test whether there is any significant difference to means. That means we are going to test whether there is any significant difference between the means of 2 samples, X1 bar and X2 bar. And alpha value not given, we can take alpha equal to generally 0.05 or 5% level of significance. Standardly, we are going to take alpha value is 0.05. Like the procedure of test of hypothesis, H0. There is no difference between the means of the 2 samples. And alternative hypothesis H1, there is a difference between the means of the samples. Actually, X1 bar is 210, X2 bar is 220. And alpha 0.05, this is common because it is two-tail test. Two-tail test because X1 bar not equal to X2 bar. When it is right tail or left tail test, if you take the greater than value, we can write as right tail test. If it is less than value, we can write as two-tail test. Now the test statistic, S1 square and S2 square values are not given, only S value is given, 10. So instead of S1 square, we can replace with S square because taken from only one population, which is state now. That's why. So 210 minus 220, where X1 bar is 210 and X2 bar is 220. By under root of S1 square, instead of S1 or S2, we are going to replace with S. S1 is 10 and S2 is 12. 2 different sample standard deviations are given. So there is no worry about S1 or S2 equal to sigma. So 100, 150, second sample size 150. If we simplify this term, we are going to get Z equal to 7.14. So mod Z equal to also 7.14. And Z alpha is 1.96 from the level of significance. Compare the mod Z and Z alpha. In conclusion, mod Z greater than Z alpha. So we are going to reject the null hypothesis. We are going to reject the null hypothesis according to the procedure of the test of hypothesis. So what is null hypothesis? How we defined X1 bar equal to X2 bar. This is we are going to reject. That means X1 bar not equal to X2 bar. Is it true? We'll verify. X1 bar is 210 and X2 bar 220. Both are not same. Na? We have proved also both are not same. That's why our procedure is correct in the problem number 2. Now, if we go to another problem with different values. See, a sample of students drawn from 2 universities, University A and University B. The students, number of students we have chosen from one university, similarly another university. and their means and standard deviations are calculated and given in the table. What our question is, test the significance difference between two means, x1 bar, x2 bar. Now we see the table. The university A's total number of strength are 400. The first sample size is N1. University B sample size is N2. Both two are large samples. Now its mean, the first sample mean x1 bar and second sample mean x2 bar. First sample size SD S1 and second sample size S2. And alpha value is not given. We can take 0.05. All values we know that. So which test is suitable? Exactly test of hypothesis for difference of means only, because two large samples and we are going to test whether there is any difference between two means. So we can use test of hypothesis for difference of means. Now again the test of hypothesis procedure H0. We are going to assume there is no difference between means of the two samples. Means of the two samples. x1 bar 56, x2 bar 57. And we are going to define H1 alternative hypothesis. There is a difference between means of the two samples, alpha 0.05, which is also two-tailed test. Two-tailed test. So Z alpha is 1.96 for two-tailed test at alpha equal to 0.05. The test statistic formula, Z equal to x1 bar minus x2 bar by under root of s1 square by n1 plus s2 square by n2. Instead of sigma 1 square by n1 plus sigma 2 square by n2, we are using s1 square by n1 plus s2 square by n2, because we don't know what are the values of sigma 1 square and sigma 2 square from the problem, but we know that s1 square and s2 square values from the problem. That's why we are going to replace according to the concept of the test of hypothesis for difference of means. x1 bar 56, x2 bar 57 by 10, where s1 is 10 is given, 10 square by 400 plus s2 also given, which is 15 whole square by 100. If you simplify, z equal to 0.632. Mod z is 0.632. And z alpha value 1.96 from step 3. Now if you compare these two values in step 5, we can write the conclusion. Mod z 0.6, z alpha 1.96. Mod z value is less than z alpha value. Mod z is less than z alpha value. That's why we can accept null hypothesis. We can accept null hypothesis. That means H0 is x1 bar equal to x2 bar. That means we are going to accept this one. That is, the means of two samples, the means of two samples are same. Like this, we should solve the problems on test of hypothesis for difference of means. Blindly, we should remember, in case if the problem consists of one sample, large sample, we are going to use test of hypothesis for single mean. In case the problem consists of two large samples, we can use test of hypothesis for difference of means. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.